Now let's look at the next question. Solve in positive integers, such that root x plus root y equals to root 3051. So let's first spread this out by square both sides. So square of root x plus root y equals to 3051. And this equals to x plus y plus 2 root xy equals to 3751. Now you can subtract x and y to the right side. So 2 root xy equals to 3751 minus x minus y. Now you can also again square both sides. So 4xy equals to 3751 minus x minus y squared. Let's see a number in root, so a number x. How can we take the x, some part of x out of the root? It must follows that x has a form of a squared times x1. So you can move the a squared out of the root, become a root x1. Let's see whether xy has this property or not. So let's let x equals to a1 squared x1 and y equals to a2 squared y1. So this follows that a1 root x1 plus a2 root y1 equals to root 3751. And this, it follows that x plus y plus 2 times a1 times a2 root x1 y1 equals to 751. So you see, this is an integer and this is an integer. This must be an integer. So x1 y1 must have the properties of a number squared. So let's first suppose that x1 does not equals to y1. So if x1 does not equals to y1, then it follows that this number m squared must divide x1, or m squared must divide y1. However, we know that we make the x form as x equals to a squared times x1. So x1 is must a number that cannot have the form of m squared, because we have put all of the m squared out of the x and we made that become a squared. So this does not exist, same as y1. Therefore, we have the conclusion that x1 equals y1. So now let's look at the original question. So this becomes a1 root x1 plus a2 times root y1 equals to root 3751. And since x1 equals y1, we have a1 plus a2 times x1 equals to root 3751. Now you see that this is an integer and this is a root. Let's see whether root 3751 can convert to a number times a root. So after we find that out, that equals to 11 times root 31. Thus we solve the question. You see, a1 plus a2 equals to 11. Thus, a1 equals to 11 minus a2, and x1 equals to 31. Thus, x equals to a1 squared times 31, and y equals to 11 minus a1 squared times 31. But this is not true for all a1, because a1 plus a2 equals 11. So we must denote a1 as bigger than or equal to 1 and less than or equal to 10. Thus, we have solved the x, y in positive integers. Now let's look at the next question. Find all integers x and y such that x to the fourth plus 4 times y to the fourth is a prime. So let's first try to expand that, because we see this is a form of a squared and this is a form of b squared. And in order to simplify that, we can add 2ab and minus 2ab. Thus, x to the fourth plus 4y to the fourth, that's x squared plus 2y squared. We need to plus 2 times x squared times 2y squared. That's 4x squared y squared. So we need to minus 4x squared y squared. Thus, this becomes x squared plus 2y squared minus 4x squared y squared. And we see this is another form of this is 2xy squared, so we can simplify that as x squared plus 2y squared plus 2xy times x squared plus 2y squared minus 2xy. And you can take 1y squared out of the 2y squared to make it x plus y squared plus y squared. And this is x minus y squared plus y squared. Thus, the question becomes, find all xy such that this number is a prime. However, the prime number only equals to 1 times its value. So this must be 1, and this must be the prime number, or this be the prime number and this be 1. So now let's see the first situation. So if x plus y squared plus y squared z equals to 1, there are only several solutions. First, y squared, this must be 1 and this becomes 0. So y can be 1 and x can be -1. Another solution is y equals -1 and x equals to 1. Let's make sure that when we plug in this, that it will be a prime number. So -1 minus 1 squared plus 1 squared, that's 4 plus 1 equals to 5. 5 is a prime number, so this is correct. And 1 minus -1, that's the same, we got the same value of 5, so this is also correct. Let's see the second situation. So x minus y squared plus y squared equals to 1. Thus, y squared equals to 1, and y can be 1, so x must be 1. And y can be -1, and x must be -1. So, to verify that, we have 1 plus 1, that's 2 squared, which is 4, plus 1, that's 5. -1 plus -1, that's -2 squared, we get 4, plus 1, that's 5 again. So these 4 are all the combinations of integers x and y, and we solve the question. If you have any question, please contact my email. See you next time.